On behalf of TPM, I'd like to welcome you to today's webinar. My name is Bruce Harris, and I'm a Senior Technical Solutions Consultant here at TPM. I'm heavily involved in our Reality Capture division, as well as I'm our Revit MEP specialist here.
Hey, I'm Lee Peace. I'm a TSC here at TPM, and I'm also a scan tech for the Reality Capture. So I want to talk a little bit about our agenda today. We're going to start with a intro into scanning, just the basics about what scanning is and how we do it. Point clouds and modeling for digital twin. A little bit about plant layout. Point clouds and mesh technology. And meshes in design software.
So let's talk a little bit about 3D laser scanning. Now, I don't know how, I'm sure in this diverse a group, we have a lot of people that understand it really well and some that don't, but we're going to kind of start at the basics here. There are lots of reality capture methodologies out there. They all have their advantages and disadvantages. On the low end of accuracy is 360 cameras. What we typically use in our laser scanning services are terrestrial-based laser scanners. Those are the ones that are based on tripods, but we also have SLAM technology scanners as well that we use. And drone these days are both based on photogrammetry, and some of them even employ LiDAR as well. Time and place for each of these technologies. And what we try to do as a company is match up your needs with the technology that fits you. So let's talk about, terrestrial-based 3D laser scanning. What really is it? It's LiDAR plus HD photography. So when we're running a scan, it's literally capturing millions of points a second, and each of those little dots are the point cloud. Now, those dots are colorized by the photography that it takes as it's scanning, so that the point cloud itself, even though it's not photorealistic, seems somewhat realistic and gives you an idea of textures and colors and that sort of stuff. The beauty of 3D laser scanning technology is you never miss a measurement, so it captures everything. Now, it is a line of sight technology, so we just don't put one out in the plant in the middle and have it scan and it captures everything. That's not the way it works. You have to scan from multiple positions to make sure you get all the angles and can capture everything and get enough data on it. If you only scanned a pipe from one side, you would only have half of a pipe. So you want to make sure as you're laying out your scan map, if you're mapping a facility, that you've got enough overlap to not only register the scans, but give you a very good point cloud with enough detail to capture what you're looking for.
So I want to talk a little bit about the different scanners. First up on the list is the BLK 360 Gen 2. This is an extremely fast scanner with a very low entry point price. This is the low entry scanner. It is extremely fast, and you can get a scan of a room in about 8 to 10 seconds. It throws out around 680,000 points of measurement a second.
Now, on that very low range, you probably want to crank it up. So some of the scans can take much longer than that too, depending on how much detail you want to capture.
Exactly. Its highest rate scan is, I think, 1 minute and 50 seconds. Next on the list, we have the BLK to Go. This is a SLAM-based scanner. It actually uses a technology called Grand SLAM. So as you're walking around with the scanner, it is using both visual and LiDAR to figure out where exactly it is as you're walking around with it. So you don't have to set this one up on a tripod. It's literally you with the BLK to Go walking around collecting data.
We use that a lot in like areas where they have a lot of small rooms that would take a while to get in and out of a terrestrial scanner. It's awesome to be able to walk around that kind of thing with this.
Office environments, small areas, it's great for. And then we have our workhorse. It is the RTC 360. This is the primary scanner that we use. It has great distance and amazing accuracy, and it is extremely fast. So most other scanners of this caliber are taking between 7 to 8 minutes to scan. The RTC is able to get a scan in about a minute and a half. If we cut down all the settings and just do black and white, we can fly through an area at a speed of about 30 seconds a scan. With photography, you're getting a complete 360 view of the area. It's accurate to about a 16th to an 1/8 of an inch, and it's sending out 2 million points of measurement a second. So it's actually sending out 4 million points of measurement a second, but it's only using 2 million of those points. It's deciding on the fly which one of those is giving it better data.
Now, next up, we're going to discuss digital twins. It's an acronym that people are throwing around, has a lot of different definitions to a lot of different people. So we're going to talk about point clouds and modeling to have that digital twin. Now, if you ask 10 people right now what a digital twin is, you'll probably get 10 different answers. So I'm going to give you kind of a generic definition, but I think it's a pretty good definition of a digital twin. A digital twin is a virtual representation of an object or system, could be an entire facility, that's designed to reflect a physical object accurately. Now, certainly a point cloud in and of itself answers this capability, can give you all the measurement capabilities you need and captures existing condition. And no matter what you're going to do with your digital twin, you're going to start with some kind of reality capture. But the second part of the definition is, I think, really what a digital twin truly is. It spans the object's life cycle and is updated in real time and is used to help make decisions. So not only is this a single point in time capture, but to really get the most out of a digital twin, you are constantly updating that digital twin as your facility changes, embedding information in this digital twin that allows you to make decisions. You can even link it to FM type facilities management systems. So that's the concept of a digital twin. Now, this piece of software that we're looking at right now is a free viewer from Leica. It's called TruView. The wonderful part of this is we can get a lot of information from the point cloud itself. Now, this is a free piece of software, so it's not restricted to those that have design software to be able to leverage data. It's, available to any stakeholder. I clicked on one of those red dots. When you click on a red dot, it takes you to that scan position. So those red dots are the different scan positions, and you're literally seeing the photography here, but it has the data behind the photography of the point cloud. Now, what I'm going to do now is I'm going to turn off the photography and look at simply the point cloud. And you can see what we were talking about earlier when I was talking about how it colorizes those points based on the photography. So you do get a really good feel of the actual materials that were there. And although it's certainly not photorealistic, it gives you a fairly realistic environment to work in off the point cloud itself. Now, this point cloud, we can do things like fly around it, which I'm not going to do right now, do all kinds of different visualization things, but I'm going to go over here and I'm going to take a measurement. So let's say we wanted to know how far it is from the floor to the bottom of that beam. So it's giving me all kinds of information, but the DZ, which is the change in the Z elevation, is the actual elevation, because obviously the 2 points I picked wouldn't perfectly line up from point to bottom. Now we can do the same kind of thing, say from the side to side. So if I wanted to go over here and click on measure again, measure distance, click on a point on one side, click on a point on the other side. And this time it's the change, the D and Y, that is the actual distance between there. So this tool gives stakeholders a lot of information that they can use, and we'll show you using this tool in conjunction with meshes and other data a little bit later on in this presentation. Great tool, and it's free. Now, some of the file formats it can open are an OBJ, which will do that to bring meshes in here. And also another file format that we're going to be dealing with and talking about is IFC. So as we go through this presentation, we'll talk about both of those and how you might leverage those two formats. Now, we actually offer a modeling service. So if you want a model of your facility as the end result of the scans that we're creating, this is going to give you an example of the type of detail that you can get from it. Now I'm going to go up here and click on my section box and bring the roof down just a little bit so I can see kind of in there, and you can get a better idea of the detail that's involved in this. But this is the kind of detail that you can expect out of modeling. Now, although you can use the point cloud itself as your digital twin, I think most people would be much better served by having a model, because we can embed data in that model and do a lot more with it as a model. Now, this is model of all the disciplines. So there's architectural model there, there's structure, there's all the different MEPs. So there's piping, plumbing, electrical, cable tray, all of that different stuff. Now it's Revit. So I clicked on this piece of equipment. It's a mechanical pump. I go into edit type, and I've got all kinds of data that's automatically associated with mechanical equipment. But Revit is a database basically under the hood, so it's wide open for you to use and create any kind of data that you need to track. So you can schedule it, export it out to a database, link it with FM, any of those needs you might have. Now, this is that same little model exported out to an IFC file. IFC can be really convenient in exchanging between different formats. In fact, that's what it was designed to do, is BIM packages that don't natively talk to each other. It's designed as an exchange format. So this is going to be an example of using IFC. So this is SolidWorks in here. Now, SolidWorks is a design package that natively doesn't do point clouds very well, to be quite honest with you. So bringing the data in as an IFC is a wonderful thing. And when you bring it in as an IFC, you can notice the tree over there on the left. These are all smart objects that understand what they are when they come in. So, you know, if you select an object over in the tree, it highlights, tells you what it is. You can control its visibility and know all kinds of information about it, and obviously design in conjunction with it here in SolidWorks. So IFC gives you a very good exchange format to get that data into SolidWorks as a model that you can actually use in conjunction with your design. Now, this is a really good example of combining point cloud technology, a BIM design and Revit in this case, and a package called Twinmotion to bring them together, bring it to life, and make a presentation. This is actually our new Charlotte office. This is before we moved into it. So this is in the demolition area. So this is a scan we made before everything was redone in our office, but we're combining it with the BIM that will be. So this is what will be. This is what it is. So we're combining those two technologies to make a compelling presentation that shows you, you know, what it will be. And in our case, actually, we've already moved into this Charlotte office. So in our case, it's what it is.
And there's not much difference between the two.
Yeah, it's a great presentation tool. And, you know, it allows you to bring in, you know, management and other stakeholders to actually visualize and understand this data in a different format that you can't do otherwise. Now, let's talk about some things we can do to basically combine our point cloud data and other types of data and look at some plant layout or reconfiguration techniques. Now, this is back to that free viewer. This is the TruView viewer. And in here, I've got a arm. Now, this was also scanned, but it was converted into a mesh. And Lee's going to talk in great detail about meshes here in a moment. But this was converted into a mesh that allows us to place it easily and move it around in our point cloud facility, so we could see how it's going to line up. We can see what kind of measurements it would take once we place it. We can move it through openings to make sure it's going to go through the door. All kinds of different things we can do. And because this is a free viewer, this allows people that don't have design software or maybe design expertise to be able to leverage this data and look at some ideas of moving things around and placing things in our environment. Now, this is going to be an example of a combined point cloud and model. Now, obviously, in a lot of design packages, we can bring in a point cloud, can be a very integral part of what we do. In fact, our modeling team, that's what they do. They bring in the point cloud in Revit and they model based on the point cloud. But what I'm going to show here is combining Revit data that's modeled with the point cloud and how you can use the two in conjunction with each other. So let's go ahead and flip this up in 3D. And you can see I'm using the same building and that same model for this situation. I've got the model inside the building. So the point cloud is the building and the Revit data is the rest of the MEP systems and stuff that are in there. Obviously, we could do that the reverse of this. We could have the building be the model and all the MEP stuff be a point cloud. That's 6 1/2 dozen of the other. But the gist of this is we can combine the technologies in this environment and use them quite effectively together. Now I can do something like a floor plan here. As you notice, the cut plane of my floor plan is working in conjunction with the point cloud. So I see the openings like I would want to see if they were regular modeled objects. I can also do things like sections. Now see where my pointer is there? That's the depth of this section right here. So if I move to that section, that's how deep I'm going to see in the model. So you can see we can create a sections. The top section here, I'm going to click on it and you'll see that it's going to actually go beyond the wall. So we'll see to the wall when we go to that data. So now we're seeing that section through to the wall. So the main thing I want you to get out of this is when we're using the point cloud in our design software, we can get sections, elevations, 2D views, all of that we're used to getting in a combined environment, and obviously move things around and work with things and make sure that our layout is going to work.
So I want to talk a little bit about advanced techniques in point cloud and mesh technology. But before I do that, let's talk a little bit about what a mesh is. A mesh is a simplification of complex data. That is, it's taking all the points from the point cloud and making them into surfaces. So one of the cool things is you will lose some of the accuracy, but it makes the data processing a lot faster. Because the data is easier to work with and faster, it's easier to import and export into different programs. Because it can be opened in more programs, basically anybody can look at it without the need for specialized programs. So here's an example of making a mesh out of a point cloud. This is a Cessna 310 that's been mounted at the local airport. We took multiple scans from several locations in the parking lot and even put a handheld scanner on a pole and reached the top area. We cut out the area that we wanted to keep, and using the software, we extracted the mesh from the point cloud. There were a few areas, if you notice, that it had to fill in, specifically on the top of the plane itself, where we just didn't get high enough, but it was able to find that difference. So you may be wondering, what use is this to me? Well, let's take a look at our print lab, for example. We took the machines from our Charlotte office and wanted to know if we could fit them all in our Greenville office. So I took a scan of the Charlotte office and took individualized meshes of each piece of equipment. So for every machine, I made a small mesh. And then I was able to put that mesh using TruView into the location that they currently are. This is our Greenville office. Once I put them all in the point cloud, I was able to maneuver them around and just make sure that they were all going to fit where we wanted them to go. Primarily, as you can see, I'm trying to line up that venting system with the vent on top of the HP machine. And we were just making sure that that was going to fit in the vent. And we can now take a look at and see how everything looks in its place. Nice. So next, I want to talk a little bit about meshes in design software. So this is a mesh of 2 meeting rooms at TPM. As long as the area is relatively simple and not a complicated area, this is the fastest way to bring it into most design software. We're able to convert point clouds into a few different mesh formats. We can use the GLB, the OBJ, the PLY, and STL formats, along with a few others. But those are the most common ones that we can transfer it to. Skip that slide. Yeah, so as long as we keep the area small, this is the best way to bring it into most design software. Let's take another look at the process. Here we have a point cloud. This is once again the Charlotte office, but as I was scanning it last time, there was a small scissor lift up there. And it just so happened that I was able to scan it in pretty good detail. So what I did was cut out just the object that I wanted to turn into a mesh. And then I extracted the mesh from the point cloud. Using Scan to 3D and SolidWorks, we can extract surfaces and faces from the mesh, and we can then design off of those surfaces. We can also sketch off of surfaces in Fusion 360. And objects can be imported straight into software like Blender and other editing software. So one of the big advantages of a mesh is they are minuscule in compared to the size of the actual point clouds. The point cloud of that building was over 10 gigabytes, and I have the mesh of the airplane, the building, and the piece of equipment and it is roughly 170 megabytes. So it's greatly cutting down the size and the effort of your machine to bring it into most software. If you want to find out more about 3D scanning, we're having an event at our Charlotte office, and you are more than welcome to come join us there.
Yeah, that event's going to be on September 12th, and it's going to be during the afternoon there from 1 to 4 in our brand new Charlotte office. We'd love to have you there. Please come visit if you're in the area.
Let's take a look. Is there any questions about what we've talked about today? And again, if you have any questions, you can use the Q&A at the top of the screen.
One question, Lee, that we got was, what software were you using to create these meshes?
I was using, it's a software from Leica called 3DR, and it has the ability to extract meshes from point clouds, and it also has a bunch of analysis tools that actually comes in handy a lot. We can also use Geomagic DesignX software to extract meshes and also import some meshes directly into design programs such as SolidWorks.
Excellent, excellent.
So our the system at TPM, anything bigger than our refrigerator, we usually scan with our scanners, the RTC or the BLK2GO.
Right.
If it's any smaller than that, we have the RTEC scanners.
Yeah, and people may not be able to see the question and answer. So the question that was asked is all this just looking at buildings and layouts, different systems, or are you wanting to scan small parts to reverse engineer? So like Lee was saying, we do have a whole division that's designed nothing but reverse engineering, and they typically use the RTEC scanners for anything small. And not only can we reverse engineer them, we can print them for you as a service as well. So we definitely offer those services. This particular seminar wasn't designed with that in mind, but I'm sure we will have one in the near future that will talk about that particular aspect of our business.
Yes, this recording should be available after the presentation.
Yeah, I'm not sure how long before it's before we post it, but if you're attended this, or even if you registered and didn't attend, if you have one of your cohorts that did that, they should get a link to this recording.
You want to hit that one?
Which one?
Can you describe a bit on how you go about making the models after you obtain the point cloud? Particularly curious on how the challenge process of completing items which you cannot scan on all sides in a model, such as pipes.
Yeah. There's definitely an art to converting a point cloud into a modeled objects. As far as something like a pipe, that's why you want to capture it from multiple locations, so you have enough of the pipe so you can determine the diameter of that pipe.
Usually it's about a quarter of the pipe, 2/4.
I think you really want at least 30% or more
to get a good shape.
To get a good shape. You know, and hopefully we capture more than 30% of most of the things we do. Now, if it's a piece of pipe that's way up in a ceiling, you know, we still even that way can capture as much as 50% of it, depending on how many times we hit it from different directions. Now, our modeling team, that's all they do every day is they do nothing but model from point clouds. So they're really, really good at it. I don't really do that all the time, so I'm not nearly as good at that. But yeah, you have to know what you're trying to model, and you have to make sure you have enough data to give you what you need to do that. Now, there are some software out there that can do some semi automatic translations, you know, where they, you know, you can click on a pipe and they can go, oh yeah, this is a round object, boom, it's a pipe.
The accuracy of the RTC 360 is
1.9
1.9 millimeters
at 10 meters.
At 10 meters, yeah.
Which is, you know, somewhere between a 16th and an eighth of an inch. I think realistically, you can look at an eighth of an inch as a realistic expectations to get out of most scans.
Uh, we've even gone less. I mean,
Oh yeah, we can do better than
yeah,
that.
yeah. Depending on the object, we've gone down below 16th before. Just it depends on how we're scanning something.
Yeah, it depends on how close we are to the object as well. Accuracy is also a function of how close you are.
Mm-hmm.
So if we had a big part we were reverse engineering that was too big to use with the RTEC,
Then we would get multiple scans with it and turn up the density of the point cloud.
and scan it from a closer distance than 10 meters too. So which means we would get a much higher accuracy.
Yes. So how long does it take to scan a typical building?
If we're looking at capturing just a fairly wide open manufacturing environment, I would say we can get somewhere in the neighborhood of 40 to 50,000 square foot in a day.
Yeah.
So that kind of gives you a ballpark. Obviously, it does vary depending on the density of the building and some other situations.
If there's a lot of equipment stacked on top of each other, I
Yep.
mean, then that will slow us down a little bit.
Absolutely.
Just because we want to make sure that we're capturing everything for you. So we do offer training on the scanners after a purchase.
Absolutely. Absolutely. And we offer training on the scanners. We offer training on the design software itself. We offer training on combining technologies. We offer training on all those things. And the fact that we're both a SolidWorks and an Autodesk reseller means we have a lot of training opportunities available to you.
Hey, Chris, I'm still looking for an alternative to CloudWorks.
Yes. We haven't got a great alternative to CloudWorks yet in the SolidWorks environment. I was really sad to see them close down development on that product because that was an amazing tool in SolidWorks. So we're still looking for the tool to replace CloudWorks in the SolidWorks environment.
I imported the mesh with Scan to 3D into SolidWorks. It did not create the mesh straight from the point cloud. Any kind of complicated point cloud kind of bogs down SolidWorks, so I turned it into a mesh beforehand.
You're right. And we also saw bringing in ISC into SolidWorks too. So
yes.
So typically you're not going to be using a point cloud in SolidWorks, which goes back to Chris's question, which when CloudWorks existed, which I'm really sorry to see that product go, we had a great solution for using point cloud data directly in SolidWorks. Not so much right now. We're still looking out there. Hopefully we'll find a product that will fill that void.
Question about reflective surfaces. They can be an issue, but it's not a bad issue. It's just something that we have to clean up in post-processing.
Well, yeah, but this is another example of the difference between the right tool for the right job.
Yes.
For instance, the Gen 2 instrument, it doesn't do nearly as good a job on reflective surfaces or very dark surfaces as the RTC does. So that's one of the things you get by stepping up to the higher instrument is the amount of accuracy you're going to get on really dark surfaces and reflective surfaces. And like Lee said, unfortunately, there is some cleanup involved. When we scan, the time that we specify that we're going to charge you for scanning includes the cleanup as well. So for every 8 hours we're out in the field scanning, we typically have about 4 hours of cleanup in the office to get a nice looking point cloud. Things like mirrors are always going to be a problem. So
yes.
So we have to clean up some data. Also, I don't see a question on this, but also an important thing is moving objects. And we have lots of different ways that we can deal with removing objects. We've got the double scan capability and the RTC. And, if it's not in both scans, then it automatically eliminates it. But there's some pretty powerful tools built into the Register 360 software in Leica that lets you remove moving objects as well.
Free software is for converting scans to mesh. So one that just came out recently would be reality capture. That's from makers of Unreal Engine. While I haven't done a lot of testing, it is pretty promising on what it can do. It also does photogrammetry as well. Outside of that, Cloud Compare can do some basic transforming. It can transform a small point cloud into a PLY file, which still has the points, and it's very heavy file, but it can work in some softwares.
I think the key here, though, is if you're going to do a really good job in converting to a mesh, it's going to take a piece of software that you're going to have to pay for, like 3DR that you were talking about is a great example. And Geomagic, if you want to go on the high end and get some really high end, amazing meshes, Geomagic just blows me away with that.
Oh, yeah. It's amazing. Yes, we do offer services in other states.
Oh, absolutely. We're located out of our Greenville, South Carolina office, but we not only cover the Carolinas, which obviously we drive around those and do that all the time, but we go all over the United States and do scans. So that's not a problem. It just adds the expense of travel on top of the normal scanning fees. We don't charge additional fees other than just travel expenses and that sort of stuff.
Yes.
So we're very affordable.
At one point this year, within a 30-day period, I was New York, Texas, New Mexico, and Milwaukee, Kentucky too.
Yeah.
Yeah. All within the past year.
Yeah. So we move around. We're very capable of going anywhere you need us to go. We can even go overseas, but we need to really talk about that before we would take an overseas job, because there can be some other logistical issues with going overseas.
Yes.
Any other questions? Or I believe that might have it.
I think that's it.
Well, once again, thank you very much for attending our webinar today. We look forward to starting to do some of these on, a more
regular basis.
Yes, a more regular basis than we have in the past. So we're looking forward to doing those. And for those of you that were interested in reverse engineering, I don't know a particular date, but I do know we have one of those in the process of doing so. If you're on our mailing list or however you got this one, I'm sure you will receive information on that one as well.
Or you could join us in person at the 3D Scanning Live in Action event at our Charlotte office.
Excellent point. Excellent point. Thank y'all very much for attending. Look forward to working with y'all in the future.
Yep.